So D9 is another special formula related to the power rule. Okay, so another special rule. So supposing n, or the exponent, is equal to -1. Okay, so instead of using the power formula, which could be very time consuming to do, so if this is the format, then we can just use this formula, this rule. So if your n is -1, so this one over u to the power of n is just the same as u raised to the power of n minus 1, right? Using one of the laws of exponents. Sorry, it's negative n. All right. So let's try to derive how we ended with -n over u to the power of n plus 1 times du over dx. So if we have our y as u raised to the power of -n, so using power rule, so we have y prime is equal to -n. Now you copy the power, okay, and then copy the base, and then the exponent will be reduced by 1, okay, and then multiply it with the derivative of the base. So -n minus 1, that can be written as negative of n plus 1 if we put the negative sign outside, and then times du over dx. And if we transform it back to an expression containing a positive exponent, so we put it below, no? So we have basically -n over u raised to the power of n plus 1. Okay, we make the negative here positive using one of the laws of exponents. So we have here the result. So as you can see, okay, -n over u raised to the power of n plus 1 multiplied by the derivative of u with respect to x. So that's how we derive using power rule. So to make the differentiation process shorter, so we can use this special rule. Okay, so applicable to 1 over u to the power of n format. So the first example is similar to one of the examples in the quotient rule. Okay, so we assigned 1 as our u and 20x minus 3 as our v from that rule. So let's try solving this using D9. Okay, so this can be expressed here as u to the power of n, where n is 1, because it's just a linear function. So the u therefore is 20x minus 3, and our n is 1. Okay, so that we can use this formula. So if you have that given function and we want to get its derivative, so we simply write, okay, the n meaning 1. So bali the exponent of the function here. So it's -1 over, okay, u to the power of n plus 1, raised to the power of n plus 1 rather. So we copy the base, or the u, which is 20x minus 3, and raise it to n plus 1. So if n is 1, then 1 plus 1, okay, multiplied by the derivative of the u, which is the derivative of 20x minus 3. Okay, or that's -1 over 20x minus 3 quantity squared multiplied by derivative of 20x minus 3 is 20 minus 0, or 20. So it's -20. Okay, put the negative sign here. In the materials, learning materials or the notes. So the negative signs are placed on the numerator because um maybe ba no ang makita is the negative sign is part of the fraction bar. Okay, so just for emphasis, no, the fraction is really negative. But here we can clearly write no the negative sign before the fraction bar. Okay, so let's see if we have the same answer using the quotient rule. So it's here on the side. So we have quotient rule, this one. So we have negative 20 over the square of 20x minus 3. Okay, so it's either using quotient rule or using the special rule. Okay, so example number 2. Okay, so we have our base, the u, it's x cubed, no, minus 5x squared plus 2x minus 2, and the n as, or the 3 rather, as our n. Okay, so 10 is just a constant, so we can just multiply, no, the 10 with 1 over this one below. So, padaplin lang na daan si 10, no? And then proceed to application of the D9 rule. Okay, so it's 10, no, times. So using D9, we have negative n. Okay, yeah, divided by u raised to power of n plus 1, then the derivative of u with respect to x. Okay, so that would be multiplied by, so n is 3, so negative 3 over, so observe ha the pattern, so balik-balik lang yun na you simply write negative of the exponent, so negative 3, okay, divide it by the, copy the base, and then instead of subtracting 1 from the exponent, you add 1, no? Because it's already in the denominator. So if nasa numerator, then minus 1, but it's in the denominator. So you add 1 instead. Then multiply it with the derivative of the base. So derivative of x cubed minus 5x squared plus 2x, okay, minus 2. So we have negative, this is negative 30. No, 10 times 3 is 30 over, okay, x cubed minus 5x squared plus 2x minus 2, quantity raised to the power of 4, and then derivative of this one, derivative of x cubed using power rule is 3x squared, no? Copy the exponent and then reduce the exponent by 1, then minus 5 times the derivative of x squared is 2x, so that's 5 times 2x, or that's 10x. Or you just multiply, no, the exponent with the coefficient here para mas dali. So, meaning 10, and then from x squared, it becomes x. And then if we have an x term, so you simply copy, diba, the coefficient. So, derivative of 2x is 2. And for the last one, it's a constant, so its derivative is 0. So it's just 3x squared minus 10x plus 2. So observe the pattern for power rule. Okay, decreasing na ang exponent. No? Kung x cubed, it becomes x squared. If x squared becomes x. If it's x, then x disappears. Okay. Then for the constant term, so its derivative is 0. So it's gone, not together with the x here. So we have, we can distribute, no, the 30 to the 3x squared minus 10x plus 2. Okay, or in the notes, they are not being multiplied, or yeah, it's written as 30 times 3x squared minus 10x plus 2. But again, you can also multiply them. So let's try na multiplying them. So it's 90, no? X squared. Then it's minus 300x. 30 times 10x is 300x. Then 30 times 2 is 60. So for the denominator, so ayaw na tao nag-expand. No, it's already correct as long as the original u is present, so that you don't have to get the product or the result of raising this to a power of 4. So this is already your final answer. Okay, so that's how you apply the special rule. Okay, special case if n is -1, derived from power rule.